3 pages, so to speak, 3 just like front pages. There'll be a front, back, and the other. I'm going to give it to you over the course of 2 days. So tomorrow you'll end up with 2 pieces of it, and then the third piece I'll give you on Friday, so that hopefully time-wise we're not super cramped. The first question is realistically 9 questions. And so it's going to be one of those situations where I give you a graph that looks something like that. Okay, something weird. And it's not going to be a specific function. It'll be on a coordinate grid though, so you can find all these points. So let's call that -6, 5. And let's call this x-intercept at -5. And we'll call this minimum down here at -3, -4. And we'll grab this maximum up here. We'll call that point 0, 3. And then down here at the minimum, we'll call this 2, -3. And then that's going to go off to forever. And our, oops, missing my x-intercepts here. So we'll call this one at -1. We'll call this one at +1. We'll call this one at +4. Okay. So these are rough numbers. The graph I'll give you tomorrow will have a coordinate grid on it, so you have to go find these points. And they will go through nice like crosshair pieces for you, so they'll be easy to identify. And then I'm going to ask you a whole bunch of questions. So I will ask you domain, and I'll write out the word domain, so you know that it's domain. And then you're going to tell me the x values, because that's our domain. Domain in this case, I'm going to start at -6 and include -6 because it's got a filled-in circle. And then I'm going to go on for forever because of that arrow, so this will go to our positive infinity, always a curved bracket. Range will be written out as the word range. This is the only time you're going to be using y. The only time we talk about y values being in interval here. So our y is the lowest y I've got is a -4. The highest one I've got is it goes on for forever. So in this case, we're going to go from -4 to infinity. Again, square bracket because we include that bottom point. Next piece is going to ask for your x-intercepts, which I will ask for the zeros, and then in parentheses it'll say x-intercepts. So these are literally the coordinate points of your x-intercepts. So you're going to give -5, 0. You'll give -1, 0. You'll give +1, 0. And 4, 0. Okay, so those are all of our x-intercepts. Then we'll ask local mins and maxes. So the local mins and maxes are not the true, like, just the local part. So not necessarily the maximum of the equation or the minimum of the equation, but the local piece. So the local parts are just your peaks and valleys. If you have multiple valleys, then you have multiple local minimums. So in this case, our 2 local minimums are at -3, -4, and at 2, -3. And then our local maximum is just at the top here at 0, 3. Okay, so these are your valleys basically, and these are your peaks. Okay, even though this goes on to infinity, or even this end point here is an initial point, we're not going to look at those. We're going to look at just the peaks and the valleys for these local mins and maxes. The next piece that we'll ask for is where is it greater than 0, less than 0, so where are we positive and negative? That'll be written as f of x is greater than or equal to 0. So when am I above 0 or equal to 0? Again, now we're only talking about x values, so x is an element. We'll see we're above 0 in that section, and in that section, and in that section. Okay, so we're going to have 3 pieces to this. We'll go from negative 6, which we include because it's an endpoint, all the way up to negative 5, which we'll also include because I want it to be greater than or equal to 0, unioned with negative 1 to 1. We'll include both endpoints, again, because of the greater than or equal to part to this. And then we'll union this with negative 4 or positive 4 to infinity. So 4 gets included. Infinity is always a curved bracket because we can't quite grab it. Then we'll look at where is f of x less than 0. And in this case, we're looking at these two pieces below the graph. So we're going to look, because there's no equality, these ones will have curved brackets. So we'll go from negative 5 to negative 1, unioned with positive 1 to positive 4. And then the last piece we need to look at is the increasing and decreasing stuff. So I'll actually use the words increasing and decreasing, but for the sake of space on this flip chart, I'll just use the arrows. So where is f of x increasing? And you would say, oh, well, we're decreasing, 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 increasing, decreasing, increasing. So we're going to have two increasing pieces and two decreasing pieces. The first increasing, and increasing and decreasing, we'll always use curved brackets because either the initial point or our max and mins, we're going to call that a constant because the rate of change is 0, so it won't be increasing or decreasing. So we'll be from negative 3, that's our x value here, and then we'll increase all the way up to 0. We'll union that with, down here at 2, x is 2, all the way to infinity. Curved bracket, so 2 to infinity. And then we'll be decreasing in the other spots. So again, I'll use the word decreasing on the test just so there's no confusion, but we'll show a downward arrow right now. And we're going to be decreasing from negative 6 to negative 3, unioned with decreasing from 0 to 2. So that is pretty much everything I could possibly ask you about this except for y-intercept. Okay? But those are your first 9 questions, so to speak, on the first problem. Yes, Liz?
For the increasing, why is it a curved bracket next to the infinity sign?
So infinity will always have a rounded bracket because it's not a number I can actually grab. It's a concept. And for increasing and decreasing, we'll always use curved brackets on both sides because the initial point and the end point, so when I'm turning around here, the slope at that point is technically 0, so it's not increasing or decreasing.
So those are always going to be
Correct. We'll use square brackets for domain, range, or greater than or equal to 0, basically. Yes, Moses?
Then if it's less than 0,
Why are they curved here? Because I don't have equality. So where it's actually equal to 0 at my intercepts, I don't want to include those points because it's not equal to 0, it's just less than 0.
okay.
So we'll have curved brackets. Yep. All right, next question will be even and odd function stuff. I will tell you an even function is where your f of negative x equals your f of x. Okay, so if we remember, this is the reflection across the y-axis. So this is the thing where both my positive and negative inputs will go to the same output. This is how we'll check it algebraically. And odd functions are going to be where all of my negative x's go to a negative y. So if I have negative x's, then it will equal our negative y. Okay, that's that reflection across the origin piece. So if we have the equation y equals 4x to the third minus 2x, then let's see what that is, even or odd, okay? Or neither, could be neither. And so in this case, I'll check, there's my f of x, so I don't need to change that at all. The book uses the letter k, just because it wants to look at some constant. Are you guys more comfortable with using x's still or k's? The x's, okay. So the only reason they do that is they think it's less confusing because x is a variable, k is a constant. But I'll show it with x's for you then. So if I plug in negative x, this will be 4 times negative x cubed minus 2 times negative x. And I want to know, is this equal to my f of x? So 4x cubed minus 2x. And so as we look at these negative numbers, it's basically negative 1 to the third power and x to the third power. So negative 1 to an odd exponent will always be negative 1. Negative 1 to an even exponent will be positive 1. So in this case, this becomes negative 4x cubed minus a negative 2. So this becomes plus 2x. Clearly, when we look at this, we go, oh, those are not the same. So this is not an even function. Okay. So then, because I don't want to do the same work multiple times, I want f of negative x to equal negative f of x. This is negative f of x. So I've already solved for that. I'm just going to figure out what negative f of x is. So this becomes negative f of x, which is negative times 4x cubed minus 2x. And so I'll distribute that negative to both parts. And so we end up with a negative 4x cubed plus 2x. And now we can compare those together. We say, oh, hey, those are the same. So in this case, I'm like, ching, that is an odd function. Okay, and we're good there. Yes, Ben?
Is this sufficient enough on the test to be able, because you can plug the equation into the calculator and look at the table. Is it, like, efficient?
You could. I want you to prove it algebraically. But if you can look at the calculator, show the table and show what your logic is. And as long as I can see that you understand that, yes, all my negative x's and positive x's go to the same y's, then I'll be like, okay, he gets that that's even. Or all my xy's go to negative xy's, I'll be like, okay, he understands that's odd. So as long as you show that, then I'll be fine. Just don't write even or odd. Yes, Regan.
So what is a neither answer?
So neither answer would be if I ended up plugging in this and it was not odd also, then it would be neither. An example of that would be, let's say I had plus 12 at the end here. If it was plus 12 at the end, which I'll do in a different color just so we know I put that in late. If I had done plus 12 at the end, obviously the plus 12 at the end here, this is still not even. And then if this was a plus 12 at the end, we would have plus 12 on that side, but this would be a negative 12. So those would not match up. Then it would also be not odd. So something like that. So that's the first page. The second page of stuff you're going to see tomorrow is going to be the absolute value things. So you can see something like absolute value of 2x minus 3 over 5 is less than or equal to 3. Just making stuff up. So here you want to isolate the absolute value. So you would multiply both sides by 5. So 2x minus 3 still in the absolute value is going to be less than or equal to 15. Then we would split this into our two equations. That's how we undo absolute value. So first one is the exact same. Just drop your bars. Second one is the same inside. Flip the relationship, make it negative. So in this case, we'll end up with 2x is less than 18, which x is less than or equal to 9. Here we'll have 2x is greater than or equal to negative 12. So x is greater than or equal to negative 6. Okay, that's an acceptable answer. I'm not going to force you to put it in an interval notation. If you're feeling really good and confident about it, you may. So this would tell you that x is an interval from -6, because I'm greater than it, less than 9, so this would be -6 to 9. Again, that will not be required tomorrow, but you may do that if you want. The other absolute value that may be a little bit tricky we haven't seen before would be like an x. Absolute value of x plus 2 is equal to absolute value of x minus 3. And so in this case, the absolute value is already isolated, so you can split them into two equations. The thing to be careful about is the first one stays the exact same, which is typical. The second one, I like keeping my left side the exact same, and then you're going to make the right side, the entire right side negative. Okay, so that makes it into a negative x plus 3. Okay. So from here, now solve both equations. We'll subtract x from both. We'll see we get 2 equals -3. The x's disappear. That's not true, so that's not a solution. Over here, we'll add it, so we end up with 2x, and we'll subtract. So 2x equals 1, or x equals 1/2. And so our one solution in this case would be x equals 1/2. If you think about it graphically, hopefully that kind of makes sense, because you end up with a graph that was shifted left 2 units and a graph that was shifted right 3 units. And so their only intersection point is that one point, which mathematically worked out to x equals 1/2. Okay? These two lines are parallel. They'll never intersect again. Okay. Then we'll go and take a look at the discontinuity piece. So you have your f of x equals some equation like x squared, minus 9 over x minus 3. And then the second piece of our piecewise function will be this letter c, which is some constant we want you to plug the hole with. Up here we see that x cannot equal 3, and down here we want x2 equal 3, so we can plug the hole. And so I'll ask you to graph it, and then ask you to plug the hole and find the value of c. If you factor out the top, you're going to see that that's an x minus 3 times an x plus 3 over x minus 3. So everything on top that's x minus 3 cancels with everything that's on bottom, which is x minus 3. So this graph is going to behave like x plus 3, because that's what's left. And so basically you have the function of x equals x plus 3. So that's a line with a slope of 1 and a y-intercept of 3. However, you have that situation where at x equals 3, you have a hole, because I can't divide by 0. And so you want to know if x was 3, so if f of 3 were to exist, because the rest of the graph behaves like this function, this should be 3 plus 3, or f of 3 should equal 6. That tells us this coordinate point is 3, 6, and so c needs to be what? 6. Okay? Y equals c, and c needs to equal your y value, so you can go back and plug this hole. Okay? So that's the discontinuity piece. You'll tell me the value of c, and you'll show me that graph. And then I will ask you a absolute value story problem. So let's say Dylan likes to play football. Okay? Let's say Dylan on average makes, how many tackles do you think you get a game, Dylan?
8.
About 8? Okay. So he gets 8 tackles each game. Let's say he has a rough game and he only gets 5 tackles, and maybe in a great game he got 11 tackles. So we're going to say that this never varies by more, I'll use delta for change, never varies by more than 3. If I want to express this as an inequality absolute value, I can say that the number of tackles Dylan makes, x, minus his average number of tackles, the distance from there, is never by more than 3. Okay, so the actual amount minus the average in absolute value will be less than or equal to what it varies by. Then I can go and figure out how many tackles Dylan makes on a typical game. So we can say that x minus 8 is less than or equal to 3. X minus 8 is greater than or equal to negative 3. And so when we solve both these, we'll see that x is going to be less than or equal to 11. X is going to be greater than or equal to 5. So this will tell us that the range of tackles Dylan makes is between 5 and 11 in a typical game. Okay? But this is the trickiest part, being able to express that as an absolute value expression. What the actual is minus the average is less than or equal to the variance. Okay? So that'll be the pieces that you will see tomorrow. The stuff you'll see on Friday is going to be some more of the graphing stuff. And the thing that'll take the longest is the piecewise function graph. So the first one you'll see is I'll give you a function, let's say it looks something like that. And that point is 2, negative 3. You would be able to take a look at that and tell me exactly what the equation is based on the vertical and horizontal shifts. You'd be like, oh, well that is y equals, my parent function is x squared, so I'm going to shift it right to, oops, put the x in there first, shift it right to, and down 3. And so I'd be like, all right, sweet, there's the equation of that graph with vertical shifts. The next question I would then ask is, given something like y equals the absolute, let's go negative, absolute value of x plus 2 minus 4. Okay? And you'd be like, oh, well, this is an absolute value. It's going to be upside down. It's going to be shifted left 2 and down 4. So I would take this over 2, down 4. And then I would have a slope of negative 1, and I would have a graph that looks kind of like that. Okay, and so you'll plot those points a little bit more accurate because you'll have an actual coordinate grid to work with. But in general, we'll be shifted left 2, down 4. I'll have that slope of negative 1, so to speak, off of this down 1 over 1 from our v. Okay. Next one is going to be, I'll give you something with asymptotes. Let's call this 2. Let's call that negative 2. And then we'll have a graph that looks like this. Okay. Hopefully we recognize that that's 1 over x squared. You're not going to need to know that for this question, but I'm going to ask you end behavior stuff. So just like the book has been starting to show it, I'm going to say as x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? As x approaches, and here's kind of a hint for you, I will have the vertical asymptote identified because I'm going to have it approach that so you can see tail behaviors. So as it approaches, in this case, negative 2 from the negative side, y is doing what? And as x approaches negative 2 from the positive side, y is doing what? Then I'll also ask you for the vertical asymptote and the horizontal asymptotes. Okay. So in this case, as I go towards positive infinity, as x disappears this way, we see that y approaches 2. As x approaches negative infinity, as we head that way, y approaches 2. As we approach negative 2 from the negative side, y is going to disappear off into the positive infinities. As we approach 2 from the positive end, y is going to disappear off into the positive infinities. So all you'll need to do is plug in those green pieces. Okay? Then the vertical asymptote. Vertical lines are written as x equals a number. So this should be x equals, and then in this case it would be -2. Horizontal asymptotes are horizontal lines. Those are written as y equals a number. So y equals, in this case, +2. So you'll have to identify the asymptotes and the end behaviors. The last piece that'll take some time, and why I'm going to split this into 2 pieces for you, and you'll do this on Friday, is I'm going to give you a piecewise function and have you give me the graph for it. So we could have something we'd have something that looks maybe something like that. And again, there'll be coordinate grids so you can figure out what your slopes are, but for the sake of the drill, I will give you some coordinate points so we can find the slopes now. Let's call this -7, 4. Let's call this -6, 3. Let's call this 0, 6. We'll call this 3, 3. And we'll call that last point 5, 3. Okay, so based on that, you should be able to find the slopes and y-intercepts of those 4 lines. And then you can build your piecewise function. So the first equation, okay, I'm going to call this equation number 1, call this equation number 2, call that equation number 3, and equation number 4. Okay. I know that my slope is going to go down 1, over 1. So we have a slope of -1. My y-intercept, you can either continue that pattern over until you hit your y-intercept. So in this case, if I went down another 6 and over, or sorry, down another, how far am I going? Yeah, we're going to go down 6 over 6. That would take me over to -3. So I have the equation -x minus 3 for equation number 1. And then equation number 2, my slope, I'm going to have a rise of 3 and a run of 6. So this has a slope of 1/2. I give you the y-intercept there, so I know that this is +6. For equation number 3, again, we're going to go down 2. Nope, down 3. Going down 3 over 3, so this has a slope of -1 again. And a y-intercept of 6, because that was given to us. And then lastly, equation number 4, that has a slope of 0, and it goes through a y-intercept of 3. So this is just y equals 3. And so in this case, we can find our function of x as a piecewise function. The equations are -x minus 3. It behaves like that from -infinity to x equals -6. So this is for all values where x is less than or equal to -6. And then the second equation is 1/2 x plus 6. It behaves like that between -6 and 0. So this is for -6. Because of the cap, it's just going to be less than. And then a solid circle there, so x less than or equal to 0. The third equation is -x plus 6. And then it's going to behave like that from 0 to 3, not including either endpoint. Because of the caps. Remember, these caps tell us they're basically open circles. And then the last piece is just 3 for all values where x is greater than or equal to 3. That gives us our final piece.